Yeah, so if you look at this, you will see the 12 boreholes. This was actually done, and we're trying to establish just, we've actually not talking about other Pathfinder elements here. We just want to look at the relationship of these two minerals we've actually identified here, whether they are genetically related, what is the relationship between two of them, and all that. Later on, we're also going to be looking at the relationship between them and other Pathfinder elements like arsenic, like the cadmium, like the iron and the sulfur. Do you understand? But right now, if you look at this is lead-zinc cross-section correlation. We've tried to remove anything that is less than 5,000 ppm. So all the things you see here are greater than 5,000 ppm. And you can see the notation here. This is for zinc, and actually the triangle one is for the lead. Now, looking at this is borehole 1, 2, 3, 4, 5, 6 to 12. And you can see the depth. This correlation is respect to depth. So if you look at here, you will see there is a fix here already between 10 and 15, just mean looking at this graph. And you can also see, so if you look at here, borehole 3 is very interesting in terms of zinc. So in general, you can see that this is more of zinc, you understand, contained everywhere, because the lead actually is like an early phase at this particular location. So based on this, you can also understand that there is nothing much in 11, and possibly 2 was actually out because nothing was actually found in 2, you understand. But from borehole 1 to apart from 2 and 12 to 12 was actually some interesting interception here. Then looking at it, you see this is actually divided into 3 zones, horizons, A, B, C. So you can see that A is from 80 to about 20. You can see that there's a strong this is actually where we have a strong X of 8 here in terms of lead. There are some other interceptions, differently that was done, at different intervals, at this particular location. Then also you look at zone B, the mid 24 to 10, from here to 36 or thereabout, that actually you can see there is an interesting interception of zinc here. And also the zone C is the deeper horizon, the deeper location from 40 to 45 high zinc in this borehole 6 here, and borehole 12 also. The borehole 12 and borehole 6 actually definitely this correlate with respect to depth, even though they're a bit far away. So you can see, but so what actually happened here? So you see there must be some a kind of a fracture work here. There were kind of a weaker interception around here, but definitely what's here and here actually correlates. And in 12, there is also a deeper interception in 12 down to, below 45 meters. Then let's go further to also look at the correlations in terms of other, trying to look at using other parameters. Here we use log scale. So to show that you can see the regression trend here is also positive, that the length is actually increasing, the zinc is also tend to increase too. So this actually implies that they are genetically related, definitely introduced by the same hydrothermal fluid system, or maybe say the same mineralization episode, So this actually shows a very linear correlation here. Also, there's also 2 distinct geochemical populations, which was also shown in the other one. You can see on the lower lead zinc, side of it from here, and to that of here, you can see that there's a diffuse disseminated mineralization or kind of a halo alteration zones. And also this suggests 2 mineralization stages of fluid pulses, like in stage 1, the lead is richly early phase. The lead actually galena actually deposited possibly in a higher temperature oxidizing fluids. That's why in the other one we saw it at the early stage. And the second stage here, the zinc is dominant phase. Later column reducing precipitating sphalerite actually must have actually come out at the later stage. So that is it there. So let's go further also you can see we try to also use a computerized system-wide zonation between lead and zinc ratio versus depth. You can see the kind of curve we see here. It also definitely shows you a tree kind of zonation here. Upper horizons here, A, the another horizon, B, and another horizon, C. You understand? And the depth approximately here is 0 to 15. Here, lead is greater than zinc at this particular location, and the ratios are just 0.1 to 1.2. So galena is actually rich and oxidized upper zone. Definitely, actually what happened here, proximal to fluid entry, or maybe structural conduit at this particular zone. And the second zone, which is between 15 to 30, between 15 to 30, this particular zone here is the mixed, where we're kind of a transitional zone, where we'll have a mixed lead and zinc zone transition from early galena to later sphalerite deposition at this particular stage. That is the area we call zone B. And the lower zone, which is at this particular stage, is from 30 to about 35. Zinc is actually greater, deep zinc enriched here zone. This is actually dominant. This fluorite is actually dominant. We can say of a reducing condition. Actually, what's happening here. Then, so based on that, this is the plot we've actually done to show you there are three actually zones in the entire system as the project actually goes on. Definitely, I'm going to show you more. So based on this, you can see that we're actually dealing with more of zinc in this location and with some relationship. So based on this, we're going to also be tracking down on some other relationship to help us see how we can actually drill, do some kind of step out drilling in this particular project.